Hello everybody, this is Mr. Bowman. Today we're going to be looking at literal equations and inverse equations. So these are two type of equations that work very similarly. So a literal equation is the actual definition of this word, which means letters, all letters and words. Okay. So what that means is, for the most part, you're going to have few, if any, numbers in these equations. Okay. So we're going to start with one of our more famous ones, d equals r times t. Or it's used in science quite a bit as distance equals rate times time. Okay. So maybe you want a little background on this. If you wanted to say find how far you went if you were going 60 miles an hour and it was 2 hours, you would multiply those two together and find out 60 times 2 is 120 miles you went. So that's how this works. Doesn't really play into what we're going to do right now, but just in case you were curious what I mean when you use this in science. All right, so whenever you're getting a literal equation, it's going to tell you solve for something, maybe r. They have to tell you what to solve for, because usually these are solved for a number already, and if they're not, you still don't know what to do. You could solve for any one of the letters, and it doesn't really matter. So they have to tell you which one to go for. So this part is tricky for people to think about because they're letters instead of numbers, but it doesn't change at all, okay? So it's still, if I want to break a multiplication, I'm going to do a division. If I want to break an addition, I'm going to do a subtraction, etc. Okay? So if I want to solve for r, I want to get r by itself. So I forgot to draw my line here. Right now I have r times t. That's multiplication. How do I break a multiplication? Division. So I want to divide by the one I want to move. So I'm going to divide by t to both sides. This divides out to 1, so I don't need it. So it's d over t, exactly what I wrote there, equals r. It's the only thing left. That's it. Don't overthink these. Just think in terms of operations instead of letters or numbers, okay? So opposite of subtraction is addition, all that kind of stuff. That's where you want to think. It doesn't matter what the thing you're actually dividing is. It could be a smiley face, it could be a hippopotamus, it could be an ink spot. It doesn't matter, okay? So normally we do it with numbers because we're solving for the letter. But if we have a bunch of letters, we're going to move some letters. It doesn't matter. It takes a little bit of mental gymnastics to wrap your head around, but I promise it does the exact same thing. So what if, maybe we'll use a math one, I have y equals mx plus b, okay? And I'm going to solve this one for m, maybe. So I'm going to do everything the same way I did before. I'm moving things to both sides, so it's going to be the opposite of my normal order of operations. I'm just going to go to town. So I have m, I have a multiplication with x, I have a subtraction on the same side with b. I want to do them backwards, so I'm going to subtract first. Sorry, addition with b, so I need to subtract. I misspoke there. This goes to 0. These are not like terms, so I just write them next to each other, y minus b. And then this is gone, so bring down the mx. I want to solve for m. It's being multiplied right now, so I'm going to do a division. What am I multiplying by? X. I sort of said that already. So I'm going to divide both sides by x. Y minus b over x equals m. M is now by itself. I'm done. Okay? It's going to take some practice. Don't worry about that. Just do your best, take your time, and try not to overthink it. If you're getting really confused on a problem, put it down, walk away, try another one, okay? All right. This is one of the ones where you have to get out of your own head to really do it well, which is weird in math because usually we try and stay focused, but this one you can't overthink pretty easily. All right, and that leads us into inverse equations, which is a similar idea, but we're going to have some more numbers again, but we have one weird step to do at the beginning. So if I want to find an inverse equation, that means I want an equation that undoes everything that the first one does. Okay, we're going to start with a really simple one just to show you what I'm talking about. So say I have y equals 2x. Okay, what does that mean? That means anytime I have an x value, I'm going to multiply by 2, and that'll give me a y value. So let's make a quick table here just to prove that this is going to work. So let's go with 0, 1, 2, 3, 4. I'm going to plug those in. What's 0 times 2? 0. 1 times 2, 2. 2 times 2, 4. 3 times 2 is 6. And 4 times 2 is 8. Okay. We're going to come back to this in a second. My inverse one would be exactly the opposite. Instead of multiplying by 2, it's going to divide by 2. So it'd be y equals x divided by 2. And if I did this properly, then when I make my xy table, it's going to be this one flip-flopped. So I'm going to start with my y values over here. And then I'm going to plug them in. With 0 divided by 2, 0. 2 divided by 2, 1. 4 divided by 2, 2. 6 divided by 2, 3. 8 divided by 2 is 4. So I have the exact same columns, but in a different order. Instead of 0, 1, 2, 3, 4 as my x's, they're my y's over here. 0, 2, 4, 6, 8, my y's here are x's over here. So the variables flip-flop. So this one, I knew it was going to work because I made it that way. Sometimes you'll have to find that inverse equation. And we're going to use that same logic of the x's and y's flip-flopping to do that. So say I have, let's go with the normal line. Y equals 2x plus 5. What I want to do is I'm going to flip the locations of x and y, but change nothing else. Okay, so I'm going to make it x equals 2y plus 5. Okay, so I didn't change the 2, the plus sign, the 5, the equal sign, anything like that. All I did was put the x where the y was and the y where the x is. I just switched those two locations. Okay. After that, we're going to solve for y. So I'm solving just like I did before. So I want to deal with my addition and subtraction. So I'm adding 5, so I want to subtract 5 from both sides. Forgot my line. There we go. Minus 5. These are not like terms, so we just write them x minus 5 next to each other. This is 0 and is gone. 2y. Need to get rid of that 2. So that is multiplication, so I will divide and end up with x minus 5 over 2 equals y. That, now that y is by itself, is the inverse of the original one. So this one and this one are inverses. Okay, so that would be my answer.